Okay, so here's the function, piecewise. First question, the limit as x approaches -2 of f of x. Okay, so I'm going to call on you guys to do it, okay? Because I always do. It's your time to talk a bit. So, Erica? Erica, you here? Okay. Georgia?
Did we have to use only infinity and like the things at the top?
And the what? Sorry?
Like in the question?
No, just tell me the limit when x approaches -2, what is it equal to?
0?
Very good. Were you asking me? It seemed like a question. It's 0, right? You're sure it's 0?
Yeah.
Okay. We all agree, as x approaches -2, the function approaches 0, this open dot here. Okay. Limit x approaches 0. Aria? You guys, you have to answer. Aria, not here. Anita?
I wasn't sure, but I put infinity.
So when
Plus infinity.
x approaches 0, very good, plus infinity is good. Okay, if you approach 0 from the left or from the right, the function goes up to infinity. Very good. Okay, f prime of 4, Iomid, want to try?
I put 0.
You put 0, so f prime of 4. Okay, so f prime of 4, that's right here, right?
Yeah.
Well, does the slope exist here? This is a pointy part, so there's no slope. There's no tangent here. Okay, so this does not exist. Okay, understand why?
Yes.
Okay, so the function is not differentiable here because it is not, in English, it's not smooth. Okay, so differentiable means smooth for us. Okay, limit x approaches infinity of f of x. So, Evan, try.
I put 0.
Very good. 0, as you see, as x, the further x goes, the closer it is to the x-axis, or in other words, to 0. Okay, this one's a tougher one. Limit h approaches 0 of f6 plus h minus f6 over h. Gabriela? I can't turn on my mic, but my answer is it does not exist. Okay, so that's, I think it's wrong. Does anybody have an answer? Giuliano?
Is it positive infinity?
I don't think so. Irina?
I'm not sure.
Okay, try.
It's not infinity, right?
It's not infinity. Anna?
I don't know.
You don't know? Okay. Anybody knows? Anybody want to try? Okay. So do you recognize this or no? What is this?
It's the limit definition of a derivative.
Very good. Limit definition of the derivative. So basically at 6, right? At x equals 6. So basically it is here the slope of the tangent here, which seems to be a straight line. So in other words, it's just the slope of this line. Okay, so this point here is 7, 0, and this here is 4, 3. And so the slope here will be the exact answer for this one, which is the slope at 6. You with me? So 3 minus 0 over 4 minus 7, that would be -1. So my answer is -1. Okay, so that's a little tricky one. Okay, limit x approaches 2, f of x minus 2 power 2. Guillaume?
Plus infinity.
What did you say? Plus infinity?
Yeah.
Let's check it out. So when x is approaching 2, okay, so it's from the left. So I have to do both sides because at 2, as you see, it is, the limit does not exist. Okay, so let's see the limit as x approaches 2 from the left of this thing, f of x minus 2 squared, and then limit as x approaches 2 from the right of f of x minus 2 squared. Okay, so from the left here, if I approach 2 from the left, then it's approaching 3. And that's 1. And if I approach from the right, it's approaching 1 minus 2 squared. That's also 1. So from the left and from the right, it's 1. And so the limit x approaches 2 of f of x minus 2 squared, it exists and it's equal to 1. Did you understand this? Okay, so that's another tough one. Okay, so these two were tough. I think the last one was tougher. Okay, questions? Let's go. Let's keep going. Okay, I prepared a few of these. Okay. Okay, so second function, f of 2. Okay. Jeremy? What's f of 2? Okay. No, Jeremy. Fateme, sorry.
I'm not sure, but is it
Okay. What did you get?
does not exist?
I can't hear you.
Does not exist?
F of 2?
Yeah.
I don't know. F of 2. So if x is 2 here, what is the value of the function? It's where the dot is full. So it's -4.
I wrote -4, but I wasn't sure.
Well, that's the same thing as having a wrong. Okay, if you're not sure, it's like having a wrong. You can't guess. You have to be sure. Do you understand why it's -4?
Yeah.
Okay, you have to be sure. F of 2, if you pass here with a pole, where will your pole hit the function when you're at 2? It will hit it here. It's -4. Okay, limit x approaches -3. Sergio? No. Ryan?
Does not exist.
When x approaches -3, why doesn't it exist?
Because
It goes to infinity?
no. Okay, yeah, it's infinity.
Okay, very good. From the left and from the right, the function goes to the same place, very far, but still the same place. So it's plus infinity, okay? Limit x approaches -1. Marvin?
I said 2.
Yeah, and you said right. Okay, 2 is good. As you see, if I approach -1 left or right, I'm still approaching this open dot, which is at 2. Good. Next one, x approaches 2 from the left. Mubin?
is it -4?
X approaches -2. 2 from the left. From the left.
Oh, left. So
There's a
it's
minus.
-1.
-1, very good. Okay. Limit X approaches 2 of f of x. Michael?
I said it does not exist. Oh,
Yeah, you're right. Okay, 2, because from the left you're approaching -1, and from the right you're approaching -4, so it does not exist is right. Okay, and limit X approaches -infinity, Matthew?
2.
Perfect. 2 is right. Okay, good. No questions? Getting the hang of this? Okay, this has to be dominated. You're gonna get this in the final. Again. Okay, so this function here, limit X approaches 1 of f of x. So Massimo? You're answering? Massimo, you're here? Okay, Zach?
It's 1.
Perfect. No. X approaches 1, what is it? What's the limit?
X approaches 1.
Yeah, so
Does it
X is getting
not
close to
exist,
1.
or
What?
does not exist?
Yes, it exists.
So
Oh,
is it
it's
0?
0. Sorry.
Okay, it's getting close to 0. You get it?
Yeah. I don't know why I said 1.
Yeah, it's tricky. Okay, X approaches 10. Marcus Sharma, please.
-infinity.
Perfect. Okay, limit h approaches 0, f of 2 plus h minus f of 2 over h. Jonathan,
Is it 2?
what did you get? How much?
2?
2. How did you do that?
Well, I wasn't sure with how to do it, so I tried to go with the similar process you did for the last one in the first example. I know you got the slope, which was 2.
Perfect. So we're looking for the slope at x equals 2. So basically the slope right here, which is the slope of this line. Okay, so here I have point 1, 2, 3, 4. And here I have point 0, -2. You find the slope here, you get 4 minus 2 over 3 minus 0, and the slope here is 2. Perfect. This is 2. I agree. Limit X approaches infinity, f of 1 over x. Marcus da Costa.
I put -1.
Let me see. So if x is infinity, so 1 over infinity is 0. So f of 0 is -2, no?
Okay, no.
You understand?
Yeah.
Okay. Yes? Hello?
Can you explain again how you got -2?
Yeah, because if you plug in x is infinity here, you get 1 over infinity is 0 inside, and f of 0 is -2, right? If x is 0, y is -2, as you see here. You understand?
Yeah, thank you.
Okay, limit x approaches infinity of f of x. Irina?
Doesn't exist.
It doesn't exist at infinity?
I mean, it's not plus or minus, so how do we?
What do you mean? I'm approaching infinity. X is approaching infinity.
Okay, so it's -1.
Very good. Okay, and then f prime of 5. F prime of 5. So Erica?
I don't know.
Ah, you don't know?
No.
So let's do it together. So at 5, which is right here, what is the slope of the tangent at 5? So what happens at 5? You see that at 5,
Zero?
there is no, the function is not
Oh, does
continuous.
not exist?
It doesn't exist, okay?
Okay.
Doesn't exist. Okay, so basically the function is not continuous, so it's definitely not differentiable.
Excuse me, sir.
Yeah,
Say it was 4 instead of 5. Would it be 0?
yeah, very good,
Okay.
very good. Okay, next, last one. Oh, it's a bit small. Let me know if you can't read, if you can't see. So limit x approaches 2 from the left. So 2 from the left. Let me see who hasn't spoken yet. Anita,
I wrote -1.
you wrote -1, 2 from left, perfect. Okay, 2 from the left side. This is getting close to -1. 2 from the right. Jeremy,
Sorry, what was the question?
limit x approaches 2 from the right.
From the right is 1.
What did you get?
1.
1, perfect. Okay, so 2 from the right side. I'm going to close this open dot, which is at level 1. F of 2, Jialin,
-1.
perfect. Okay, f of 2 is the value of the function at 2. It's a closed dot here at -1. Limit x approaches 4 from the left. Massimo,
Positive infinity.
very good. Okay, 4 from the left side is getting close to plus infinity. Limit x approaches 5 from the left of 1 over f of x. Sergio,
I'm not sure, but I think it's 1.
you think it's 1, so 5 from the left. Let me see. So 5 from the left, the function is getting close to 0. So 1 over 0 is either plus or minus infinity here. Do you understand what I just said?
Yes.
Okay, now is it plus or minus infinity?
Minus.
Why?
Well, because it's close to minus.
Well, because I'm getting close to 0 from the minus side. So I'm getting, the function is always under 0. It's always negative. So a positive over a negative will be a negative. Okay? Limit x approaches infinity, f of 1 over x. Sophia?
I'm not sure, but I wrote do not exist.
What did you find?
Do not exist.
Does not exist. Why?
Because I don't know actually.
Okay. Well, this is a weird one. If I'm approaching plus infinity, so it's 1 over infinity, I'm getting close to 0 from the right side. Okay, so it's positive. And if I approach 0 from the right side, then I'm getting close to 1. Okay, I'm approaching 0 from the right here, and this is approaching this 1 here.
Sorry, sir, can you explain a bit how we find this? Because I was confused.
For which one? The last one?
Yeah.
Yeah, perfect. So this is the same thing as f of limit as x approaches infinity of 1 over x. Okay, and that is f of, if you want, 0, right? 1 over infinity is 0, but plus. Since I'm approaching plus infinity, so this is, I'm approaching 0 from the plus side. You good?
Yeah, I get it.
That's it. And f of 0 is 1. Any questions? Okay, did we do this question here?
No.
No? Okay, so go ahead and try it out. Okay, so here's a related rate problem. Two sides of a triangle are 2 centimeters and 5 centimeter long, respectively. Okay, so I'm going to draw them. Let's say here. Okay, something like this. So 2 and 5. And there's an angle, the angle between them, let's call it theta, is increasing as a rate at a rate of 1/2 radian per second. So right away, I know that d theta dt is equal to 1/2. Okay, that's what's given to me for now. Find the rate at which the area of the triangle is increasing. So we're looking for this triangle here. We want to see at what rate is this area increasing. So basically, dA dt is equal to what? When the angle, in other words, theta, is 60 degrees. So when theta is pi/3. There you go, that's my problem. I just need to find a relation between dA dt and d theta dt. Okay, so to do so, I need to find a relation between A and theta. Can you help me find a relation between A and theta? So the area of a triangle is base times height over 2. Okay, the base doesn't move, it's 5. 2 is a constant. I just need to express h in terms of theta, if possible. Okay, the height is right here. Okay, so what is the expression for the height?
2 sine theta.
Very good. 2 sine theta. Okay, just like you're doing probably in mechanics, you do a lot of these when you find the components of vectors, okay? Or if you want, opposite over hypotenuse, for this right triangle here, opposite over hypotenuse is the sine of theta, and you isolate h, and you get this. Okay, so I can write here as 5 times h, which is 2 sine theta over 2. And so the area is 5 times sine of theta. Okay, let's do the derivative of both sides with respect to t. dA dt is equal to the derivative of 5 sine theta will be 5 times cos theta. You guys okay with this?
Times the derivative of theta.
Sorry?
Is it times the derivative of theta?
Okay, very good. So times d theta dt. Perfect. And don't forget the chain rule here. Very important. Okay, let me see what we know. So d theta dt, we know what that is. Theta, we know what that is. And dA dt is what I'm looking for. So that's it. Pretty much straightforward. It's 5 times the cosine of theta, which is pi/3, times 1/2. Okay, cos of 60 degrees is 1/2. And so the answer will be 5/4 centimeters squared per second. That's my answer. And you see the answer is right here, the same. Any questions?
Sir,
Yep.
what was the point of them giving radians per seconds?
Of what? Oh, sorry.
Radians per seconds in the question.
What was the point of writing it as radians per second?
Yes.
Because that's the unit. That's the unit. Every second, the degree here increases by half a radian.
Okay.
Okay. So this is the related rates. I have another one here, which is on an optimization problem, but I think we're out of time.